Good morning on day 2. Today we start with Oscar Serrano from NATO.
Good morning. I came from the NATO Communications and Informations Agency. So we are the IT agency of NATO. And today I'm going to speak about cybersecurity information sharing. This is a project that we have been working on the last 4 years approximately. So first a little bit on ourselves, because it's not well known what we do exactly. So NATO, well, you all know that we work in collective defense, in particular for the 27 NATO countries, but we don't have our own military structure, so we don't have NATO forces. We rely on the forces of the 27 nations. That means that we make a lot of work on interoperability. It's important that when these forces from these different nations are deployed somewhere, that they can bring their own equipment and that this equipment is going to work interoperable. We have a lot of work also in policies for sharing information so that all these nations can work in a coordinated way, that they can share a common mission network and they make all their operations. And of course, we have our own systems that need to be protected. We have our own systems, but we also have the systems of the nations that we have to tell them how they should protect them so that all incomplete is all protected. Cybersecurity is a key concern for us, and it was stressed by our leader, by the general manager in the 2010 strategic concept, where he was explicitly mentioning cybersecurity. Based on that, we developed what is called the NCIRC, is the NATO Computer Incident Response Capability, which has 2 branches. One is the coordinating center that works more into threat intelligence, and then we have a technical center that is working more in all the technicalities of day-to-day protecting of our systems. Annually, we make the Cyber Coalition exercise. This is taking place right now. It's taking place in Estonia, in Tartu. The 27 nations and some invited nations go there and exercise about how they should actuate in case of a crisis. We coordinate this exercise, we prepare the scenarios, and the nations go there and just exercise and see that their process are okay or not. And we have many ongoing activities, particularly in cyber information sharing, and I'm going to present a little bit about what we think that cyber information sharing, how we think that it should be done. The main problem at the moment is that we are overloaded with data. We have a lot of companies that need to act. They need to actuate in different kinds of data sources, but this data that we are receiving is not coming in a structured format, and it's not coming centrally to an only place. So it's quite normal that if you are working in a national cert or something like that, you might get some information via email, you might get a PDF with some other kind of information, you might need to go to a website to look for other information. On the other way, although we get all this information and we get in a way that we cannot really work with it, we still want to have more information. So we are still not able to manage what we have, but we would like to have more. Always that's the case. So that gives a lot of problems, mainly to the people who would like to make something with that information, and mainly if your aim is to make something automatically. And that, we believe, that should be the aim in the future. We believe that at the moment, the manual processes that we are using for defending the systems will not escalate with the pace that the problems are being arise. So we have in the last year a lot of strategic drivers about how we should, that tell us, please, you need to share information. We have, for example, the CCCOE, that's the Cyber Defense Center of Excellence of the NATO that is located in Tallinn. They made a national cybersecurity strategy manual in which they speak about sharing information. We have, of course, our cyber defense policy that was endorsed by our general manager and that also stresses the need to share information. And we have a lot of national initiatives. We wrote here just 2, the US Executive Order on Improving Critical Infrastructure and the UK Cybersecurity Information Sharing Partnerships. So these are just examples of how information sharing is something that is taken very seriously at the highest levels. And we really need to do it. Yes, we don't know how to do it correctly, although we are trying. We have also a lot of operational drivers, so it's not that we want to share information just because at the high levels it has been decided that we want to share information. But the reality is that we have a lot of common systems, common threats, common vulnerabilities. We are all working on solving the same problems, and we are a coalition. However, we have too few qualified people, so we are wasting resources if we have the same people working in the same areas over and over again, when some people could just work in a piece of information and could share this with the others. So we could have some kind of burden sharing that will be much more efficient, mainly because in cybersecurity we have really problems recruiting the right people for dealing with the data that we get. Fortunately, this is not a problem that is new. So there has been a lot of research in the last years, and there are several enablers, there are several solutions that are there and that try to facilitate this work. There has been a lot of standardization efforts, and there are already some commercial software that is going to just try to facilitate the sharing of information. So I'm going to go a little bit over this commercial software and these standardization efforts so that we see a little bit what is outside there and whether this covers our needs. So there are a lot of standards that has been developed over the last years. Somehow, for some reason, the people believes that the main problem for sharing information is that we don't have the right standard. So IODEF was developed several years ago, but it was not. It didn't really gain much traction. The International Telecommunication Union has the 1,500 series, and recently, well, for several years, Meter has been developing a lot of standards. Recently, they presented STIX and TAXI. These two seem to be gaining quite a lot of traction and seems to be used in a lot of tools. So they might gain some acceptance. But still, the main problem is each organization is going to show to decide on one of these standards. So that the fact that there are so many standards is a problem because each one will decide to use one standard, and they are mostly not interoperable. And even worse, if organization picks up a standard, usually then they are going to customize it. So when you really want to exchange information, your standard will not be what the standard was supposed to mandate, and you will have problems sharing that information. So these are some examples of the standards that you can find out there. In reality, also, you have to take care that, because I call them standards, but none of them is a standard. So there has been none of them that has been really accepted as this is the standard. These are just kind of best practices. In the commercial world, there are also a lot of kind of proposals about how we should encode or share information. So based on these name standards or in other data models that have been proposed, there are a lot of tools. Some of them are quite recent, some of them not. So recent, for example, is Avalanche that was launched, I think, this year, and the same happened with Microsoft Interflow. They both do quite a lot of things right, but still we think that they are not the tools that will solve for our data sharing problems. There is the Multinational Alliance for Collaborative Cyber Situational Awareness. The Collective Intelligence Framework is a tool that is quite useful because it does not really mandate data models. You just can ingest data in whatever format, and then you can actuate on that data. And even we have our own tool. We have the NATO Malware Information Sharing Platform. This is being used by several nations to share information with national certs. The problem is this is just a tool for sharing malware information. So if you want to share something else, if you want to share threat intelligence, you will not be able to use this tool. The problem is, well, the good thing is that this is not a problem that is just our problem. So this data sharing has been a problem in a lot of other communities. So a very good example is bioinformatics. They were, for example, a long time working or they are still working in the Human Genome Project and in analyzing human genes. And they have had for years this problem about how all these groups of scientists that are working on the same data, basically, how they can share this information that they are generating. So there has been a lot of research about how this could be solved. There has been a lot of prototypes that has been done about how this could be done, but there has not been an organization who has the monetary power to build a system that will implement what all these researchers were proposing. So we believe that there are a lot of challenges in information sharing, and that these challenges are quite specific to a community, and that we need a tool that should be able to solve them if we want really to build that tool that will allow to share information and that will gain some traction in the community. Because that's also very important. If the tool is not useful for everyone, then it will be just used by a subset of people, and that makes the tool not useful. If you really want to make a tool useful enough, you need a big community of users so that you have a big pool of data. The main problem that we have at the moment is policy and legal issues. That's a problem, but sometimes it's also more an excuse than a real problem. So that's what the organizations used to say, well, I prefer not to share because I might have problems. There should be ways to overcome this problem, and I will discuss then about some possibilities later on. Another problem we were discussing is that there are many data sources, and I want to make a tool that allows me to ingest all those data sources. If I'm building a tool that just allows me to share malware information like the MISP, it's nice, it will be used by a small community, but it's not useful when I want to share threat intelligence or when I want to share any other cybersecurity information. We have a problem that we would like to use the information that we are going to collect automatically. That should be the aim. And for that, we want to have the information timely. However, we also need the information to be of a certain quality. And these are somehow competing requirements. They can be solved if there is a burden, or if there is burden sharing between a group of experts that is large enough. We can have still data of good quality in a timely manner. A point in which most of the current sharing tools fail is in this multilateral differentiated data sharing. So I don't want to share my data always with an entire community. For one piece of data, I might want to share with the entire community, but for another piece of data, I might just want to share with one organization or with one person. And I should be able to define that for each piece of data, which are the people who should receive it. And this is something that most of the tools that we have at the moment are not able to do. Another problem, and this is quite related to these legal issues, is that I'm dealing with sensitive data. I'm going to give my sensitive data to someone, so I want to be sure about what this person is able to do with this data that I'm giving him. So I want to have the control to say, I give you this data, but you cannot give this data to anyone else. And I want to be sure that the tool will enforce that. I want to tell you, look, you have my data, you can work with it, but you cannot modify it. And the tool should enforce that that happens. And this is something that does not happen at the moment. We spoke about burden sharing. We would like that if I put data somewhere that the people can see it, can be able to modify it, we can work in a collaborative manner, and that allow us to pool resources and to save money and time. And we should be able to manage uncertainty. This is also something in which the current tools fail. So basically, if I have my version of the truth, I will write or put my data. I will share this data with the community, but someone in the community might have a different idea. If they are going to change my data, currently what is going to happen is that the change is going to overwrite everything, and everything will get just the latest belief. That's not something good. The reality is that if I have my idea, the people should have to be able to see my idea. If someone else has another idea, they should be able to show this other idea, and the system should show both conflicting points of view, and then a third person can decide what he wants to believe. But he has to have all the information, not just the last information. And finally, a big problem is that there is no financial benefit. This is not that easy to solve, but basically there is little financial benefit to share information. There are risks associated with sharing security information, but there is little money to gain out of it. So we believe that the tools, the standards that we were discussing before are good. They should continue, but that we need other ideas. We need to think a little bit differently if we want to solve all these problems. So now I'm going to introduce some ideas about how we believe that some of these problems could be at least partially mitigated. The main point is that until now, all the work that has been done is mainly aimed at the data models. So it was a lot of work as how we are going to encode the data that we are going to share, how we are going to transport this data. But the reality is that being this an important part of work, there is other parts that are even more important, or at least as important, and they are inside the organization. So at the moment, we see, for example, when we make our cyber coalition exercise, that there are a lot of problems about the people who has to share the data. They don't really know if they are allowed to share that data. So if there is a memorandum of understanding to share data at some level, but this information is not known below, when you have to share the data, these people ask to ask for authorization, and they have to spend 1-2 days until they find out that, of course, that's authorized. That's a normal data exchange, and they could have done directly. This is a lot of time that is lost in something that would not be necessary if the tool will be able to somehow encode these agreements, and the tool will know what the people can share and cannot share. And because in cybersecurity, all these challenges are common to all the nations or organizations, then we think that we should aim for a common infrastructure that can be used by everyone. So our idea is that we are able to develop something that we can freely give to the community so that it can be used by everyone. So this tool should have 3 main objectives. One is to be able to manage the big quantity of data that we will receive. The second is to be able to share this data. And the third one is to automate based on the data that we receive. So we don't want to have data because we want to have data, but we want to be able to take automatic decisions based on this data that we receive. For this, we need, of course, collaboration. We need well-defined exchange policies. We need to be able to encode in the system which data can be exchanged with which partners and how this is going to be exchanged. And we need wide adoption. We need a lot of people to use this tool so that it's useful for all of us. We have been working, as I said before, for several years on the definition of such a tool. We identify high-level requirements of this tool. We reduce this to 11 so that it's more or less manageable. We believe that these 11 requirements are all necessary in order for having a tool that will gain wide acceptance. And we wrote a report that is publicly accessible. It's probably like 100 pages. So if someone has the time and the will to know more, they can contact me and I can provide you a copy of it. This is just an overview of what these requirements are. So there are requirements that are quite straightforward. So for example, that we were speaking about the number 4, it has to be customizable and control multilateral sharing, so I should be able to decide to whom I want to share the data, and that's in every case. We have other requirements that are also quite straightforward. The 6, we want to have human and machine interfaces. That's because we want automation, so we want to have application programming interfaces. We have others that are more NATO related or more related to our organization or to security organizations, like the number 5. So we have a secure network, we have a restricted network. Somehow we need a way to be able to synchronize what is happening in those 2 networks through the air gap that is in that networks. So I'm not going to go into detail on all of them, but I will explain now how we think that we can implement some of these requirements. First, this is how we think that CDXI, is how we call this tool, could be deployed. So we will have a layer of application, of enterprise applications that will provide authentication, data storage, and other core services. And CDXI should rest on those enterprise applications and take advantage of what is underneath. It will have its own graphical user interface. This graphical user interface will be basically the user interface that we will use for administration of the system, for creating the different data models, the exchange policies that we will use for sharing data. And then there should be some application programming interfaces that will allow the integration of CDXI with the automatic applications that will perform several defense tasks. CDXI will be deployed in other organizations, and of course it will allow exchange of data. So it will not only manage the data that you have, but will allow to share data as part of being a knowledge management platform. For sharing data, we need to have some kind of information exchange policies. So someone at the organization level, at whatever level, will need to be able to create an information exchange policy. This policy needs to be approved by the legal department, and when it's approved, it will be stored in the system in a machine-readable encoding that can be XML, for example. This policy should be quite comprehensive, so it should say, for example, what is the scope of the data sharing, what are the participants in that data sharing, because I don't want all data to be shared with all the people. I will explicitly state what happens if a new participant wants to join, what happens with the data that was already shared. He has rights to see it, or he will just join since the moment in which the policy takes place. I will have to have some concerns about which data quality I'm going to share. So do I want to share all my data or only the data of a certain quality? And also, it's very important, the things about intellectual property. So if I create this data sharing agreement for sharing data with someone, does this person that receives the data have the right to redistribute my data or to modify my data? This I can decide it there. Also, I can, at this level of the policy, I can already state the anonymization requirements, or which attributes will be anonymized during the data exchange. So all this will be done at whatever level of the organization, but it will have to be approved by someone that has the authority to approve it. And once it's approved, the system already knows. So if someone, operator, wants to exchange information, he knows whether he can exchange it or not, because the system will tell him, yeah, you are allowed to exchange this information. The policies, I forgot to mention, they will have to be stick to every data that I exchange. So somehow it will be watermarked into the data. That means that when the receiver receives a piece of data, it will receive the piece of data together with the policy, and that way we can enforce that the policy is always applied to that piece of data. Now, we have the way to control how we are going to disseminate the data, but still we have to find out which data we are going to share with whom. For this, we think that a solution will be to have some kind of knowledge markets. We could have private knowledge markets, in which this knowledge market one, for example, will be just for companies A, B, and Z. And we have other knowledge markets that will be public and which everyone can use. The idea is that organizations will publish data offerings to the knowledge markets. These data offerings are basically a schema saying, okay, I'm sharing this data schema, and then basically the information that is contained in the policy that we described before. So I'm sharing this schema with these persons under these conditions. The participants that are allowed to download these data offerings will be able to go to this knowledge market and will be able to see it, and then will be able to subscribe to those data offerings. That is something similar to what you can see, for example, when you are going to download a torrent file. You will go to a website and you will find what you want, and you say, okay, I want to download it. Once you have subscribed to this data offering, what will happen is that the CDXI instance will be informed that someone has subscribed to that data offering, and then the data exchange itself will be totally independent of the knowledge market. So the data exchange will be between the CDXI nodes. That's decouples a little bit how we find data from how we transfer it. The knowledge markets can be deployed by whoever that wants to host a knowledge market. Whoever organization can deploy a knowledge exchange for his community of interest, and then can somehow publicize it so that the people can find the data that they are interested in. And we are speaking a lot about data models. In reality, what we will exchange are ontologies. That is basically a data model. But the idea is that we should not be able to exchange just one ontology. So we believe that it's very difficult, or at least at this moment we cannot do it, to sit together with 27 nations plus industry plus whoever it is and to try to find out, okay, what are your data sharing needs now? What are going to be your data sharing needs in 10 years? And now let's sit all together and let's build a common data model so that we cover all those data sharing needs. So that's impracticable. And that is something that will not be solved by sticks or by any other standard. So our field is moving too quick, and we don't know what we'll need to share in 5 years. So if we want to build something that will be scalable, that will work through the years, then we need to be able to ingest data in whatever data format that is coming. It has to be possible not only to ingest this data, but also to evolve this data once we are making different versions of the same data model, because the data models itself will also evolve. This sounds difficult to make, but you saw yesterday the presentation of the key speakers. They are already making it. It's just based in NoSQL technologies using Hadoop. This can be more or less done. So based on this concept of being able to use whatever data model that you might need, we came to the conclusion that we might need to have a kind of agile data model that can evolve with time. So if we have this initial data offering that someone is sharing that has several objects with several attributes, we have said that this data offering is going to be used by a group of consumers, of organizations, that they need to consume this data, and they are not consuming data because they just want to have the data for fun, but they will use this data in some applications. If this data model was going to change because there is a new version, the applications will have to change also. And that's something that is difficult, that requires some effort. Okay. So can you hear me now? Good. So I was speaking that if there is a new company that is coming with a new requirement, so they would like to use some of the data that we have before that was shared, but he would like to use it now for advanced persistent threat detection. So in order to be able to use this data, he will reuse a big portion of the initial data offering that he has, but he would like to modify it. He would like to add attributes, he would like to add objects, and he would like to, this is going to be the data model that he will use. That should be possible. We should be able to allow for doing that. And this company should have the possibility to create a new version of this data model that will be used originally just by itself, because the other companies will not be able to use this version of the data model. It will just break the applications that they are using at the moment. So somehow we will have two versions of the same data that are coexisting in time. At some point, the other applications might decide that they would like also to reuse the improved data offering for their needs. So based on their pace, on their resources, they will be able to modify their cybersecurity applications, and then they might want to use the new data model for this new data for their original needs. So what we will have at the end is that both data models will have to coexist for a long time, and that the tool should be able to support this. And not only to support that the data models coexist, but the data has to be synchronized, because basically a lot of the objects and a lot of the attributes are common. So we would like that if someone is exchanging data in one of the two data models, this new data is reflected in both data models. So that's a problem that is not easy to solve, but that we have also been working. We have also drafted a design document about how all these things could be solved technically. Another problem that we have been speaking during the presentation is about how we will like to enable automation. So if we have CDXI and is deployed in one organization, and this organization is receiving 2 different data offerings from 2 different organizations that are more or less trusted or not, you don't really know basically what is the quality of the data that you are getting, but you know that you have data and you would like to work with it. Usually what these organizations should be able to do is to correlate this data, because you will not want to use just one data offering, but you might want to use several objects and several attributes from different data offerings and just combine it to create the data that you might use for your application. And then via application programming interface, this data will be consuming, for example, via alerting system. This is something that is quite straightforward. So now this same data can be used exactly the same by a semi-automatic response system. So if you have been following a little bit the presentation, you will see that this is not a good idea. So that you are getting data that you don't know exactly what is the quality that you are getting, and that you are using it for alerting system might be okay, because at the end, that's just going to raise an alert and you might actuate on that alert or not. But if you are going to actuate automatically on that data, then you want to be sure that the data that you are receiving is good enough for actuating automatically. So we need to have quality control processes. This is something so simple, like someone who will have to go through these data offerings and who will have to write, okay, this is my process for computing the quality of the data. For this process, these are my quality outputs that will go, for example, for 1 till 10. And now we will go through all the data, and I will give a quality value for each of the elements of this data offering. Before the data then is used by the semi-automatic response system, it will have to be filtered. So not all the data will go through this filter, just the data that is of enough quality, and this I have to define it also, will be able to be used. If I have a full automatic response system, then the situation will be that I might need another quality process. So I might have different quality values for the same data offerings based on how I'm planning to use that data, because the quality requirements do not depend on the data, but depends on how I want to use the data, or what do I want to use the data for. Creating this quality, well, not creating the quality process, defining the quality process can be easy, but going through all the data and assigning quality values is something that it's very cumbersome. So it has to be possible to somehow share the burden of creating this data. It has to be possible to subcontract how to create this quality, and it has to be possible also to share it, so the quality is itself an ontology or an attribute of the ontology that will be shared together with the rest of the data model. Finally, we have other features that I'm not going into detail in the presentation, but that I have been spoken during the entire presentation. One is anonymization. This seems quite easy when I'm speaking about it, but it's in fact a huge problem, and there is a lot of research on it. But the main idea is that I will be able to sanitize outputs based on attributes. So I will say, for this attribute, every time that you are going to share it, you have to sanitize it. And the sanitation of the attributes will happen automatically once the data is being exchanged. So the data in my database will not be sanitized, but once the data is going to be shared, it will be going through a process in which it will be substituted with the correct output, with the correct sanitized value. And then we spoke also about management of uncertainty. So this is very important when we are speaking about attribution, when we are speaking about motivation. These are things that are a lot of times subjective, and I want to be able to have the complete truth. I have to be able to see what all the people think about something, so that I can have my own belief about what the truth is. The funny thing is that although this is not implementing, I think, in any of the data sharing systems that they have seen until the moment, is something that is relatively easy. So there are nowadays multi-version databases that allow to do this. So it's not one of the requirements that is more difficult to implement. So just to conclude, we think that there is a need for a knowledge management platform, and we need that this has to be specifically tailored to address the information sharing issues that we have in the cyber defense community. So we think that there is nothing at the moment that is fulfilling all our requirements, and we are trying to work towards building something that will do it. For that, we have defined and designed a capability that we think that fulfills most of the requirements that we have in the community. But of course, this is just our point of view. So we are looking feedback from the nations, we are looking feedback from the industry, we are looking feedback from the CERTs, and whoever wants to look at our work and came with ideas, we will be happy to collaborate and to speak about it. Manisha Parmar is the project manager of this project, so you could contact her or you could contact me if you are interested in this. The idea is that in 2015, we are going to go to the nations with this idea, and we are going to ask them that we would like to implement, and they will decide. The decision, we don't know what it will be. It can be that they are going to say, yeah, please implement it as I have described it now, because you have to think we are scientists, so we might have a lot of mad ideas. And when this is going to the nations, they might see, yeah, please try it and do it. Or they might say, okay, that's maybe a little bit expensive and we don't really have, or we can live without some of the requirements that you think that are needed. So just make something simpler and more cheaper. That might be a possibility, but it can be that we build all that we are describing here. The final idea is that we will get something like this, in which we will have basically any kind of organization. We will have some kind of private, public, or community-specific knowledge exchanges, and everyone should be able to use the same tool to get the information that they need and work together with that information. That will help a lot with the fragmentation that we have now, with all these different standardizations efforts, all these tools that are a lot of times just custom made in some days, because what happens now is a lot of times you just go to a partner and want to share information. Then first you don't know even what you want to share. Once you discover what you want to share, it becomes okay, how do we share it? And at the end the solution is, let's create a SharePoint portal, and you will just use SharePoint at the end. So we want to make something more comprehensive and that is future-proof, that can be used for years to come. So if you have any questions.
Thank you very much. So this is something that's very important to me. So what I'm finding is that, yes, it would be really good to have a structured framework to be able to share this kind of information and have policies around it. But I'm running into a more elementary issue, and that sharing with private companies is working. But at least for me, in my experience in the US, the government and law enforcement there are of the mind that we as private companies should share information with them, but it's not a two-way street. And when they do give us any information, it's too old or out of date to use. And do you have any suggestions for confronting that in the sharing space?
Well, yeah, that's a problem that I was not mentioning, but it's true. Everyone says sharing is very important. Everyone wants to share, but when they speak about share, just mean they want to receive the information. They don't want to give their own information. So I have not much problems or much solutions about that, and we have the same problem. We have 27 nations. We want to share information with them, but at the end, the reality is we as NATO give them information. We as NATO don't receive much. So we believe that if you are implementing these 11 high-level requirements, that should help the governments or the entities that has more sensitive information. They will get a little bit more of trust in the fact that the information that they are sharing is more controlled And if you have more trust that in the control of your information, then you might be willing to share more. The thing is, at the moment, the tools that are there, once you are going to share your information, you don't know what's happening with them. And that does not really give you a good feeling for sharing information if you have sensitive information. So I think things like this multilateral sharing, where you define, I just share with you, and this policy that says, okay, this data comes with the policy, and once you receive this data, you will not be able to share it to someone else. We think that should help. But of course, if someone does not want to share, we cannot force him.
You mentioned OpenIOC briefly, and I wonder if you were kind of a betting person, whether you would put money on which of the many kind of platforms and standards you think are where would you place your bet?
You mean from the tools and on the standards that are existing right now? Which ones I think? So from the standards, I'm without almost any doubt that the ones that are really gaining traction are sticks and taxi. So if you want to do something and just rely on one standard, I will go for sticks and taxi without any doubt. For the platforms that there are at the moment, well, it depends what you want to use them. But Avalanche seems to be one that makes quite good lot of the things that we are saying there, and it's also based on sticks and taxi, by the way. So probably is the one that I will go for. But still, the thing is, they are Avalanche quite recently, so I wouldn't really say if it's going to be the one that will go in the future. And also, you are still restricted. If you say, I want to share with Avalanche, you will just share whatever Avalanche allow you to share. That is basically a sticks data model. If you want to share something that is not covered by sticks, then you have problems. You will not be able to do it. By the way, I like it a lot also, the collective intelligence framework. I forgot to mention that one. I like it, but the problem is also a free tool, and it's doubt how much trust you can put or how much you would like to implement it in a big organization.
Any other questions? Okay, then, thank you. Sorry.
When implementing such system, do you tend to use commercial software or do you tend to use open source? You already mentioned that.
Yeah, that's a big discussion that we have internally, or not a big discussion. As scientists, our proposal was, and it's one of the high-level requirements, we want to build this using open source. We want to build this using open source, or at least freely available software, let's say that way. This is the high-level requirement one, because we believe that this should be something that has to be distributed so that everyone can use it and we can gain traction of it. But this is not something that NATO is very good at the moment. So it's the decision then of the nations if they will accept this, or if they will decide, no, we go for a procurement process with IBM or with HP. We use their commercial off-the-shelf tools, and we pay 20 million to build a big system that we just use the 27 nations. They might decide that, but then the question is, will be useful to have a sharing system that can be only used by the nations and you don't get industry involvement, for example? We don't believe that it will be useful, but it's not our decision. We just propose.
Thank you, Oscar Serrano.